right, so this week we started a topic in sequences. A sequence is any number that has a particular order. One, two, three, etc. would be a sequence. Specifically, we've talked about arithmetic sequences. An arithmetic sequence is one in which you have a common difference between each number in the sequence. Today, we're going to talk about a geometric series sequence. Geometric is going to be a sequence in which there's something multiplied. So let's say we start with 1, multiply that by 2 and get 2, multiply that by 2 and get 4, 8. This will be a geometric sequence. If it contains a finite number, for example, 4, then we say it's a finite sequence. If it goes to infinity, then it would be followed by some dots saying we keep going, and it would be an infinite sequence. The formula for a term in a geometric sequence is whatever term you're looking for, so the first term, second term, so forth, is equal to whatever the first term is times r, which is that common number that we multiply each one by, to the n minus 1. So we need to remember a few things about exponents and order of operations. You need to apply the exponent first and so forth. So let's look at a couple of examples of geometric sequences. Let's say we know that the first term, let's say that we know that the first term, it's frozen. Hang on just a second, see if I can get it. There we go. Okay, let's say that the first term is known. Let's say that we know that the first term is 3. And we know that the common ratio, oh, nice. Okay. All right, so we know that the first term is 3 and the common ratio is 4. We can find the first 4 terms just by multiplying by 4 each time. So this would be first 4 terms, 3 times 4 would be 12. 12 times 3 would be 36. Oh, sorry, not 3, 4. 12 times 4 would be 48, and so forth. If we need the 8th term, let's see if I have my calculator down here real quick. I'll make this go faster. If we need the 8th term, we have a sub 8 would be equal to the first term times r, which is 4, to the n minus 1. N is 8, so 8 minus 1. So we have 3 times 4 to the 7th. Again, remember, order of operations, you would want to find this first and then multiply by 3. I don't have my calculator pulled up on here, so I'll just do it real quick on the side. So we have 4 to the 7th times 3, and that's going to be 49,152. So that is the 8th term. They go pretty fast, where arithmetic moves pretty slowly. So geometric is going to move pretty quickly. It's going to be some powers. It's going to act like kind of like an exponential equation. If we need the sum of the first n terms of a geometric series, in other words, if we need to find the sum of a finite geometric sequence. Otherwise, we can also call this a series. A series means you've added all the terms of a sequence. This is going to be our formula. So let's say we find the first find the sum of the first 5 terms of a given sequence. So let's say we've got 100 and then 20 and then 4. What we need is to know what the first term is, what the R value is, and then, of course, the first 5 terms means n is 5. So do we need to find the first 5 terms and add them together? We can certainly do that, but what if it said find the sum of the first 50 terms? So to find the sum of the first 5 terms, we just need to know these things here. So first 5 terms, first term is 100. 100 times the common ratio. So what are we multiplying by each time to get these values? Well, we're multiplying by a fraction because they're getting smaller. So 100 divided by 5 is 20, 20 divided by 5 is 4, and so forth. So our common ratio is 1/5. And then we raise that to the nth power, which is 5, and we put that over 1 minus the common ratio. Again, remember the order of operations, so I want to do the exponent first, and remember the fraction acts like a grouping symbol. So let's see the exponent first. Again, I'm going to use my calculator off to the side. It's almost impossible to do this without a calculator. So I have 5 to the 5th power, 3,000. So I have 1 over 3125. I multiply that by 100. So I get 4 over 25. So 100 minus 4 over 125 over 1 minus 1/5 would be 4/5. 5/5 minus 1/5 would be 4/5. And then I can find a common denominator here and simplify on the top. So I would have 1 minus 4 over 125. And then I'm just going to take this fraction and I'm going to flip it. So this is going to be 5 over 4. And then I can cross cancel and simplify. This becomes 25 and then 1, 2. This becomes 3124 over 20. Not a pretty answer, but I think that is it. Let's see, I don't think 25 will go into that. So yeah, we'll leave it like that. All right, so that's it for geometric sequences. We'll look at infinite geometric sequences separately. Those of you who are sophomores, really pay attention to that because we use this stuff a lot in calculus. So I will hopefully get together with you guys in a Zoom class soon. Haven't had a whole lot of questions yet, but I know the homework's not due until today. So let me know if a Zoom class would help you or if you want to try to do that. Otherwise, I'll just keep making these videos. Have a great day.